One of the key buzzwords we hear today is AI and machine learning that are accelerating research and development as well as process design in the chemical industry. We see applications such as experimenting on the models, predicting properties of new materials using AI, accelerating design, and just in a way that it's not as capital intensive or expensive to try out new materials before we kind of deploy them in the industry. One of the frontliers we've seen is Clariant, that is leveraging generative AI to drive company-wide innovation and is setting benchmark in the industry. If we think of share of companies that are using generative AI, this is not just AI for maintenance, but generative AI. We see that chemical firms are behind a bit in terms of their adoption. But more instances such as Clariant will drive the use of generative AI in chemicals as well. If we think about circularity, through the last 3 days, we've had an opportunity to talk to Lyondell, we've had the opportunity to talk to Nestle. Last year, we also had Braven. Some of these companies are into chemical recycling, and we see that they've been advancing their technologies. Today, we also have ExxonMobil with here today, and they'll share more on how they see innovation in chemicals. There are also several startups that are proliferating to develop chemicals from bio-based feedstocks and also reduce the G emissions to meet overall industry sustainability goals. So I'll let Carol introduce herself and talk about the company, what their offerings are, and how they are helping the chemical industry.
Okay. Green. Oh, okay. Thanks. So my name is Carol Conomos. My business is Horizon Consulting, and I'm based here in Houston. And over the last few years, I've advised mainly two groups of customers. One is energy companies, mainly in the upstream and midstream, that were trying to figure out energy transition and how to move in the direction they needed to with what technologies are available, things like methane mitigation and operational efficiency improvements. The other category of customers that I tend to work with are mid-market, PE-backed companies, maybe technology companies that are looking to grow and diversify their businesses. And so I will help them figure out how to develop their products and services into the markets. As I was working with those two groups of customers over the last few years, a couple things something that kept coming to the forefront for me was that the intersection of the need, especially for midstream and upstream customers, to minimize methane emissions, become more efficient, and then the need for power, and where those two things were intersecting in terms of challenges going forward. And so at that time, one of the technologies that I came across in my research was a technology developed by Mainspring Energy. And so more recently, I have been working with them, helping them to develop their technology into energy markets. So I'm going to give you a little bit of background on Mainspring and tell you about their product. So Mainspring is a startup. It's been around for a while, though. They started in 2010, and it's based in Menlo Park, California. The technology that they have developed was developed by 3 Stanford engineers, and they have had a number of pretty high-profile investors, as you can see, invest in their business. Khosla, Bill Gates, Hanwha more recently. and also NextEra as a financing partner. So some of the problems that they set out to solve was, how do you come up with a power generation solution that's a lower carbon solution and deployable? And so they have done that. I'll show you the technology in a moment. But they have a technology that has lower emissions than the typical competing products, which would be engine-driven coupled electrical generator sets, microturbines, and then fuel cells to some extent, but that's also a clean solution, but they don't really compete too much. Also, cost. So their technology is a very simple technology with a much lower maintenance costs. So it's a very competitive life cycle cost. And then resilience, basically an alternative that could be installed to allow you to avoid being on the grid and having, the unreliability that might come with that. And then speed to market. So, Martina Sittler with Targa spoke yesterday about challenges with getting power for their operations and a lot of the lead times going out significantly on equipment. Mainspring has been able to deploy power within about 9 months in some cases. So these are relatively small units. That the individual unit is a 250 kilowatt unit, but it's scalable up to basically any power need, as far as that would be reasonable to install. And they have done sites up to about 25 megawatts. They can, in terms of power density, you'd have about 15 megawatts per acre. And if you stack the units, you can get up to about 25 megawatts per acre. And it's fuel flexible, so they can operate on natural gas, propane, biogas, and 100% hydrogen. They do also have ammonia in their product development pipeline, but that will be probably more like 2027. And then in terms of services, they have a package where they can provide complete turnkey installation of the equipment and service packages, and they have financing packages. So let's see, I'm not sure if this is going to work. This is supposed to be moving on the screen where you see how it actually works, but it's not, so I'll try to describe it. Basically, there are 2 oscillators that move linearly back and forth, and toward what you see in the center is the reaction zone. And the oscillators have magnets mounted on them, and those move across copper coils, which is how the power is generated. There are air bearings, so the oscillators ride on air and they don't have to have oil lubrication. And then there are ports in the reaction zone where basically fuel and air enter that zone. So you compare this to a combustion engine where it's kind of similar. You have a cylinder where air and fuel are coming in, but you have combustion. And so with the combustion, you have high NOx levels, and you also have what Martina talked about as methane slip. You have uncombusted fuel that comes out as methane. So this is going to have much lower NOx and methane emissions as compared to the engines. And just in terms of markets, the units have been provided into commercial industrial businesses like Kroger, Lineage Logistics, also biogas landfill type applications, mobility and EV charging, and also just utility. So it's considered a renewable power generation source like solar or wind. So there are utilities that are deploying the technology. And with that,
Okay.
I think that completes kind of the front end overview.
Okay, thank you, Carol. So, Rajeev, tell us a little bit about your group at ExxonMobil and what do you do and what is your what are your goals?
I wish I had slick slides like this. I don't. So I'm just gonna talk. So I sit in a smallish group. It's about 10 people. Collectively, we have about 400 years of ExxonMobil experience. The uniqueness about the individuals in the group is we all major in minors. So we are wide experience. So for example, take myself. I mean, I started off in hardcore research. I have a PhD in chemical engineering postdoc. I was going to become a professor, join ExxonMobil. And I think Jim mentioned yesterday that ExxonMobil and Toyota developed the onboard reformer. Actually, my name is on the patent. So started off from there, did engineering, really hardcore operations, spent multiple years in multiple refining sites, got into marketing and sales, supply chain, strategy and planning, portfolio. So essentially that's an arc that it's not unique to me. I think all the members of my team are like that. So we call ourselves nothing fancy. It's technology scouting, innovation, and ventures. It is exactly that. Technology scouting, innovation, and ventures. So we are a very externally focused group. I mean, I spend most of my time looking outside. The group is, I wouldn't call it a CVC. It is not. We do not take equity positions, but we scout for technologies that make sense to us. ExxonMobil is quite an expansive business. I mean, upstream operations, oil and gas, refining, chemicals, our specialty business, then the lubricants business. So it spans all the way from commodity at a very large scale to almost fast-moving consumer goods, which is our mobile brand lubricants business. So our domain of scouting is what is in this space. We do take leaps that are about an adjacency away, but not too far beyond. So that sets our boundary conditions. We are typically about a step or two ahead of our business. So we are looking for things that are not here and now. The verticals are taking care of that. I mean, that's their job. They're developing the business. But what's out there? What's disruptive? And I think example would be, now it doesn't seem that crazy, but my group discovered and incubated the low carbon data center opportunity for ExxonMobil. We knew about that thing coming 5 years ago. It's a part of our job is looking for these weak signals, when things are going to break, and try to prepare the organization. So my group doesn't hold on to a lot of technology. So we'll look for things and then we want to bring it into the business and have a discussion. It's like, look, this is coming. What do you want us to do? Like, I mean, we can incubate it, or sometimes the business takes action. So that's what we do.
So that is interesting. You think of the entire value chain that ExxonMobil is active
Multiple
in.
value chains.
And then you mentioned all the verticals that you've been involved with, and the entire group has that kind of a background.
Yeah.
So
if I am scouting, I'm scouting for ExxonMobil. I do have a particular portfolio that I look out for. For example, my background is downstream. For us, downstream means once the crude comes in to the refinery or chem plant gate, from there on. So I'm looking for feedstocks, new process technologies, new ways and efficient ways of running a plant, products we can make, different pathways. These days, it's biological pathways and bio feedstocks, and somebody talked about, I think Lionel talked about plastics. That's a feedstock. So as long as it's hydrocarbon, I am interested in it. And any pathway, whether it's thermochemical, electrochemical, biological, I'm interested in it. I'm interested in making the products I make today, and I'm interested in making products that I could make tomorrow. The criticality there, or the critical metric we apply, is the scalability. We are a fairly large corporation. So for us, a 50,000 tons a year, I mean, I'll tell you how the calibration works. 50,000 tons a year is a very big volume, but for us it's 1,000 barrels a day. My Gulf Coast operation is 1.6 million barrels a day of refining. So it's a scalability, materiality is very important to us. The other thing we test for is when we look for innovations, breakthroughs that are happening, is how do we help them? Not in just write a check. It's always about 1 + 1 greater than 2. What's the synergy? Why me? What can I bring in? And that sometimes comes across support. Sometimes it comes across piloting opportunities. Sometimes it comes across as access to we're probably the only big major oil company left that has a very deep technical background. We have been innovating for multiple years. Lithium-ion batteries came out of ExxonMobil. PSAs came out of ExxonMobil. FCCs came out of ExxonMobil. So we have technical knowledge and experts that we can bring to bear. So that's, again, a very wide, expansive answer to the question. I don't even know what the question was.
Yes. So that is exactly the question, right? That do you have like a, say for example, a framework or a spreadsheet across which you will, categorize each one of these and then identify, or would those metrics and their weightages change depending on what the technology is and where it is in commercialization?
So it's not a spreadsheet. Again, all of us have spreadsheets. It's a little sophisticated than that, but essentially it's a spreadsheet. So we have a framework called discovery, incubation, acceleration. I mean, it's fancy word, DIA framework. It's not new. That's how innovations are. And before that, there is a lead generation. So we do a lot of lead generation. So talking to VCs, CVCs, incubators, coming to conferences like this, where we engage with a lot of creative, innovative people. And we go through a front screening. 400 years of experience comes handy. But then we bring it into a discovery funnel. So the purpose of the discovery funnel or step is for us to articulate a use case for a particular technology. By the way, it's not just technology, it's a product. It could be a business model that is unique. Most of the big companies have a go-to business model. This is how we do. We are either sellers or we are buyers. Okay, we do some JVs once in a while. But there are other business models that are happening. So we go through that process, and it happens very much internally within the team. If we can articulate a credible or more than one use case, then we want to incubate it. So use case is a little bit more fanciful. I mean, I don't know what the constraints are. I don't quite understand it, but I see I can use it. A lot of it is gut also. At that stage, we engage the business or experts. And it moves into our incubation phase. And actually, incubation phase is where we really define the ranges of variable, the uncertainty, what are the killer variables we must go solve, pilots, experiments, iterate. It sounds fanciful, but it's pretty messy business. It goes back and forth a lot. And sometimes you chase one use case and before you know it kind of goes in an entirely different direction. So that's the exit of an incubation phase is a business case, i.e. I can put together a cost estimate. I have a sense of what investment is going to look like. There's a big range. And what's the accretive value is going to be. If it passes that, then it's in our acceleration. At that point in time, TSNV is out. we are hunting something else, the business picks it up. And then they would go through their usual rigor of capital allocation, assessment, what the value is going to be, which market segments, all that happens. So our framework is lots of leads from multiple channels, get into the discovery, define a use case, move into incubation, define a business case, and then accelerate. An example would be very useful. And sometimes, by the way, it's not only for the external technologies. We are developing things internally too. And sometimes it's kind of funny because in the incubation phase, you have an internal technology and an external technology that are competing. And it does happen that we find the external lead is actually much more robust than internal, and we'll stop our internal programs. So I don't know if that's what you were looking for.
Yes, that's helpful.
Yeah.
So
all of us carry like multiple leads. I mean, I usually have missed for the last 3 days the morning sessions because I'm on calls. And it's between our 10 people, we probably screen 100 leads a week. 1-2 lead per person practically every day. I give 30 minutes to 60 minutes of my time to anybody. Whoever wants to talk to me, 30 to 60 minutes of time. After that, we got to think through as to what do we want to do next. Anyways, go ahead.
So on the same lines, Carol, you mentioned through Horizon Consulting how you've come across several companies who you could have helped in one or the other way. And then you are now more helping Mainspring. So what was how was your process to kind of make that decision to go with them?
Yeah, I guess in some ways it's a little bit similar in that I just in the course of what I do in consulting, I tend to talk a lot to a lot of different people, just people throughout my network, going to trade association meetings, listening to new technology pitches, and even calls where there was a call that was organized starting in COVID where people were just trying to figure out what's going on with this ESG thing. It was sort of the secret, sort of unofficial call that was happening where, people would just talk openly about, what's happening, what do we need to know about this, and what technologies are out there. Because particularly with the midstream clients, a lot of them were really struggling to figure out how are we going to achieve these goals. There were the companies were putting out big picture goals. We're going to reduce our emissions 30%, 50% by 2030. But at the operational level, the companies had no idea how they were going to get there. And they were looking at the operations that they had and saying, we have to have new technology. So they were, these groups of people are all talking about what's out there, how far along is the development, is it really to a commercial phase, can we trust that it's going to perform? And so it's kind of similar, I'm sure my process is much less formalized than ExxonMobil's, but,
yes.
But similar.
Yes.
So, Carol, how is Mainspring, distinct to, or how is it more innovative than some of the other similar players in the market?
Yeah, well, really, the linear generator concept is basically a completely totally new class of equipment in power generation. So it is novel. It is probably the first new technology in 80 or 100 years in that space. But the things about it that were most appealing to me based on my customer base and what the problems that they were trying to solve, one was the low emissions. So without combustion, the NOx levels are much lower, as well as the VOCs. But also along with that is the low maintenance. One thing that Martina also mentioned from Targa is that they have a lack of skilled personnel, so they're really having a hard time even maintaining the engines that they have out in the field that are typically driving electric generators. So if they have a technology that's easier to maintain, or they can get someone to come and service it, that is also a benefit. This technology basically just has two moving parts, where if you look at, it might compete with an engine that has 16 combustion cylinders, 16 spark plugs. So that's a lot of maintenance. And then, last was the fuel flexibility. So at the time that I became familiar with them, there was a lot of talk about the shift to hydrogen. So everyone was asking the engine manufacturers, can you get to 100% hydrogen? And I think where most of them have gotten to in the last couple years is saying that they can run to about a 10-15% blend of natural gas and hydrogen. Excuse me, I'm aware of one company that does claim that they can do 100% hydrogen in a combustion engine. But generally, there was not fuel flexibility, where this unit can run on 100% hydrogen or the natural gas or the biogas. So that's attractive, I think, as well.
That's helpful. So, Rajeev, when you scout for technologies that are truly innovative, what are some of the key challenges that you face while making these decisions to go to incubation or?
So, a few things. I think first thing is, obviously you're looking for the first question to ask is like, okay, what's so different about it? What's driving the innovation? What's the key thing? What's the secret sauce? So that's one. And sometimes you also want to look at it, if this innovation happened, things are not in a vacuum. There's a continuum. There's a customer, there's a feed, there's a process. There may be innovation in one place, and it could be substantial, but its impact throughout that value chain is diffused. That's one thing that I come across, that a lot of times inventors, founders are very focused on a piece, and they're not seeing the entire value chain. So that's one thing. The easiest way of saying what I just said in so many words is your competition is incumbent, and incumbent is there for a long time. So just one cheap thing dislodging is not going to work out. So you got to see bigger picture. So that's one. The second thing is, especially from where we sit, scalability and materiality is a big deal. It doesn't mean, scale doesn't necessarily mean it's massive. Scale means, can it be numbered up fairly quickly? Today, one of the panels talked about modular. We're thinking about building one unit and then replicating is, yes, that's scale. And it's a different paradigm. It's a more distributed model, but it is scale. They have thought through how they're gonna, stamp out parts. To me, that thinking is important. Other things, I think materiality, scalability, thinking through the entire value chain. The last one I would say is a path to truly having a product that is supported by the market. What that means is, I get it that sometimes you're stimulating the market through subsidies, mandates, support. That's okay. Immature markets need that. But there got to be a path towards how, in a mature market, this product would compete. So, I don't know if that makes sense.
Yeah, I think it does. There has to be a market. There has to be a use case that makes sense for majority of the public for that. So, Carol, when we talk about Mainspring, right? We imagine that there would be demand, but how do you see the demand for this, and going forward, and also what does it mean for the adopters in terms of what incremental capex would they have to incur to save dollars?
Yeah, so as I mentioned, I'm with them. I'm specifically focused on trying to help them find opportunity within energy infrastructure. But I'll talk a little bit about some of the other applications they have as well. But generally, target applications would be ones where they need to reduce emissions. Potentially that's for a new project or to replace existing equipment that they have out there. Colorado is an example of a place where they have put a unit and a couple units, and it was very beneficial because Colorado has some specific regulations where they want to cut their NOx emissions in half by 2030, and you just can't get there with the emission reduction technologies that are available for engines. So that was a good application. So there are definitely going to be niche locations in the country where, due to regulation, it makes sense. Also, markets where electric prices can tend to spike. California is a good example. But in general, they would be targeting applications where the average electric price is over 12 cents per kilowatt. And then potentially also, if you have a customer that's looking for equipment and they can't get it fast enough from another source, there's a speed of delivery with this opportunity. Another thing, they've provided a lot of units for like Kroger grocery stores, as an example. And I think there may be some people in this audience, that have refining businesses and retail convenience store, gas station businesses. I could see this being a very good application there as well. The units are fairly small. At the Kroger locations, they can put one of these in the space of a parking, just a parking space. So they're compact, low noise, less than 70 decibels of noise. And so it's good for applications along those lines as well. So I'll leave it at that.
Thank you. So, along those lines, Rajeev, when we talk about there being a demand, and one thing we've also been interested in, this has been a pattern through the 3-day forum that we had, is when we are announcing closures and when we are innovating and finding new technologies to maybe replace them, are we taking into consideration maybe leveraging the existing infrastructure? Now, I'm not talking about 60-year-old plants.
No, but absolutely. I think we can't forget that things are expensive. And new technology is more expensive. So, to the extent you can maximize leveraging what you have today, is definitely a good thing to do for two reasons. Not only the cost comes down, it's that new space, new technology is always risky. Mm-hmm. So the way we frame it in our mind is, it's not the barriers to entry that you want to look at. What you want to look at is barriers to exit. If you build a plant with a new technology, which costs you $1 billion, I'm just making the number up, and it doesn't work out, it's a massive waste of resources. So you really, really want to focus on, yes, I want to take the risk with the new technology, but if it doesn't work out, I'm not stuck with it. So it's a long-winded way of saying, to the extent we can leverage existing infrastructure and existing assets to prove out the technology and refine it, and give market time to mature and get more steady, that's a good thing.
Are there any technologies that you've come across that have been interesting in chemical space?
Yeah, actually, without being very specific, we are very, very keenly looking at biological things. There's still like, the cost is high and it doesn't perform better than what's the incumbent offering is. But there's some interesting work going on in the biological space that we are very interested in. So I'll share with you how our thinking works. So we always start with something small that is very niche, specialty something or the other. Then it grows as the market grows into a more bigger volume chemicals. But we're always looking for a path to fuels. It's a proxy for scale. Think of it this way, it's a proxy for scale. So we're always looking for, if I start with something that is small, very niche, very specialized, that's good. But I want to see, is there a way for me to take either this path, this feedstock, this product into larger volumes, whether it's commodity chemicals or fuels. Why do we think that way? It's because we think the two big competitive advantages that ExxonMobil brings: A, scale. And scale is not just big, it's scale, reach. We have geographical reach, product reach. The second is we are very integrated. So we can afford to think chemicals, specialties, fuels. So we try to weave that in our thinking.
That's simple. So, Carol, when you think of Mainspring, you did mention that you were looking at places where there's electricity price volatility. In terms of, say, chemical industry, how do you see their adoption for the technology, and where do you see the gaps where you could maybe fill?
Yeah, it's a good question, and I'll be honest, I might be presenting on the wrong day of the forum, because I think there may be more applicability in other markets. But one of the areas that's been brought to my attention more recently, and it's more refining, and it may be applicable in chemicals as well, would be the potential to use it with off gas from a process. And it is designed for to be able to handle quite a few corrosives, but we have not explored that opportunity specifically. So I can't say today that they could do it, but we would be interested in looking at an opportunity and see if that would work.
That's helpful. And then, yes.
I'm just going to add one more thing. I mean, more specifically, when you asked, like, what are you looking for? Biologicals, I said. Mm-hmm. I'll actually expand that. It's biological and anything that today we would consider a waste. I mean, I think Miriam talked about like plastic waste. Yes, very much interested. I mean, we may take a different track than Lyondell, but we are actually, believe it or not, very, very actively looking at CO2. Not for the sake of sticking it into the ground or taking more oil out. That's just default. It's what else can we do? Our mind has shifted towards not looking at CO2 as a waste, but a very attractive resource. We just need to figure out a way to make something useful out of it. And not surprisingly, I mean, we're not the only one. Looking at like CO2 in built environment. Can you take CO2 and replace cement? I'm making this up. I don't have a technology for it. But are there pathways where you could take CO2 as a feedstock and actually make something useful? Carbon black, all these things are, thermodynamicists are just turning in the graves. Like, what the hell are you talking about? Like, you just combine oxygen with it and you're gonna split it apart? Like, I mean, that's not free. I get it, it's not. But that's the kind of creative thinking we're going through.
So, I'm going to open this up for the audience. I do have more questions, but I'll just give the audience option.
So, Carol, I have a comment for you, but then I have a question for you. So, Carol, I'm interested in becoming a franchisee when you guys come down to the residential power level, having been through some hurricanes here in Houston. and how many neighbors generators did not come on because deferred maintenance and bad parts and things. Seems like there's a huge opportunity. I'd love to join.
Okay, yeah, I'd love to talk afterward.
Rajeev, question. How does Exxon think about these leads that you get in terms of what are you going to do with it? Buy it? Invest in it? What is Exxon willing to do, and how do you think about making that decision? Some of these early stage things that maybe have some government funding, maybe it's non-dilutive, maybe it's not. How do you walk through that with a lead?
I think I'll tell you what Exxon would. Absolutes are hard. So I'm not going to give you an absolute, but very likely Exxon doesn't take equity position, which is diluted. So if there is something that is interesting and we see a path to all the things that I talked about, scalability, profitability, accretive value, if it's early stage, we'll actually partner with you. We'll bring resources that we have, whether it's brain power, equipment, plot of land, do your piloting, testing, figure out what your killer variables are, what your operating space is, what's your sweet spot, define it, help you get there. On top of it, what we will also tell you is sometimes we redirect. Some folks are working on, they have a really good technology in certain areas. We'll actually tell them, look, there is another space that you're not seeing. There was a gentleman, I think Walter, you talked about methane and trying to make methanol out of it. There is a massive spot, and it's stranded gas. And stranded gas doesn't mean that I can't flare it. It has a knock-on impact on oil production. So sometimes the wells are cut back because companies have made commitments they will not flare. So in those cases, and it's a weird space, you can't put a big LNG facility, you don't have a pipeline, but you're not that small either. So that space is very attractive. So we'll direct folks over there. Once it passes a certain threshold, it has proven itself, we tend to take ownership. Now, that's typically for the companies that are going through the valley of death, they're developing. Now, companies that are already big, okay, you can do we acquired Pioneer, but a lot of times we go into joint ventures, and joint ventures actually are more complicated. They require a lot more thought. You want to make sure that the partners have interests, they're going to be aligned for the long period of time. You want to make sure that they're complementary. There's no potential conflict that would arise. I don't know if I answered your question, but I think I.
Thank you guys for the panel. Rajeev, my question goes to you. When you look at all these leads that you receive a week, 100 a week, you mentioned, what is some pattern or similarities that you've seen in them that you're like, this is going to work? Also, when you think of the overall, wonder if there is any leads that any innovation that you came across that you thought is not going to move forward and actually did.
So let me try to understand the question. What you're saying is, in the leads that come in, what are the commonalities I've seen lately? Okay. And then the next question was, have there been any misses? Or we saw something and it oh gosh. As a company, we have had some big ones. Okay. Let me take the first one. The leads that come across that I think are successful, or they tend to be successful, the founders move them along pretty quickly, typically are the ones where the founders have a very good understanding of what their killer variables are. So invariably, my first call ends with a question to the founders as to, what are your killer variables? And the founders that are usually very articulate and clear about what assumption would kill them, they tend to be the one very focused on solving that problem. So that's one. Now, broadly speaking, I'll tell you, I'm seeing a lot of CO2 to some X as the main leads that I see coming in. very early stage. I mean, if you guys understand TRL, these are all like 3, 4, very, very early stage. Some are fascinating. I mean, it makes you wonder, like, is it really true? I mean, but they have a product and they're willing to share with you a lot of information, but a lot of CO2 to X is. Now, what have I missed? I wouldn't say I've missed. Is opportunity that we really liked. We really liked, but we could not make a case for ourselves. I mean, I wish that founder the best of luck. They're going to be very successful. They have cracked the nut. They're going after a particular product through a pathways, using a feedstock. The business is pretty straightforward. Cheapest feed, highest product, lowest operating cost. You're going to be successful. Easier said than done. But he has those ingredients. It's just that it just wouldn't rise up to the levels what we want. So we have something called like a new market development organization. So that's trying to look for new ventures to launch. We talk about Proxima is a new venture that we have launched as a new to the world composite. We have launched a carbon material ventures. We make a lot of coke, so we got to figure out what to do with it, right? So we're trying to launch into a high value carbon product. Battery anode material is the flavor of the day, so going after that. In between, there's a plastics. Can we get something out of plastics? But within that organization, there sits a front of the pipeline that is looking for what's the next venture to launch? What's the new product to bring in? What's the new process to bring in? It has a threshold, and the threshold is, I want to launch a venture that'll make about $1 billion in less than 10 years. And this particular opportunities couldn't rise to that threshold. And I still think about it. I mean, I talked to the founder, he's doing well. But so, is that a miss? Yeah, maybe.
Thank you. So, thank you so much, the panelists. We are on time, so we'll have to wrap up. But thank you so much for your views. It was very helpful. Thank you.
Yeah,
Thank
thank you.